প্রিয় শিক্ষার্থীরা, তোমাদেরকে অনলাইন ক্লাসে স্বাগতম। আমরা অনলাইন ক্লাসের ধারাবাহিকতায় আজকে যে টপিকটি নিয়ে আলোচনা করব সেটি হচ্ছে রেকারেন্স রিলেশনস। রেকারেন্স রিলেশনস নিয়ে আমরা এর আগেও কথা বলেছি তোমাদের সাথে। রেকারেন্স রিলেশন, বিভিন্ন প্রকার রেকারেন্স রিলেশনের নিয়েও কথা বলেছি, তার মধ্যে লিনিয়ার, নন লিনিয়ার, কনস্ট্যান্ট কোএফিসিয়েন্ট এটসেট্রা। আজকে আমি এই রেকারেন্স রিলেশন রিলেটেড দুটো প্রবলেম সলভ করব। তার আগে আমরা দুটো থিওরাম দেব। থিওরাম দুটো যদিও প্রমাণ আমার ক্লাসে এখানে দেওয়া সম্ভব হচ্ছে না, তোমরা যে কোনো বই থেকে দেখে নিতে পারো। সেই থিওরাম দুটোর আলোকে আমরা দুটো প্রবলেম সলভ করব আজকে, রিলেটেড উইথ রেকারেন্স রিলেশনস। তো শিক্ষার্থীরা, তাহলে চলো আমরা বোর্ডে যাচ্ছি। আমরা linear homogeneous relations of degree 2, linear homogeneous recurrence relation of degree 2, degree 2 এর একটা recurrence relation নিয়ে আমরা আলোচনা করতে যাচ্ছি। থিওরামটা হলো থিওরাম, আমরা নাম দিয়ে দিলাম। আজকে থিওরামটাকে যদি আমরা থিওরাম নাম্বার 1 বলে থাকি, তাহলে এভাবে আমরা লিখতে পারি, let C1 and C2 be real numbers. C1 and C2 be real numbers. Suppose that R square minus C1R minus C2 equal to 0 has two distinct roots, C1 and C2. This is the characteristics equation or auxiliary equation which has two distinct roots. Last class we discussed about the roots, characteristics equations or auxiliary equations, etc. C1 and C2 be real numbers. Suppose that R square minus C1R minus C2 equals to 0 has two distinct roots, C1 and C2. Then the sequence AN is a solution of the recurrence relation. AN is a solution of the recurrence relation. AN equals to C1 AN minus 1 plus C2 AN minus 2 if and only if AN equals to alpha 1 R1 to the power n, alpha 1 R1 to the power n. There are two roots. Let C1 and C2 be real numbers. Suppose that R square minus C1 R minus C2 has two distinct roots, R1 and R2. Sorry, C1 and C2 now. R1 and R2. Because here C1 and C2 are constant, but the roots of this equation is R1 and R2. Then you can say that then the sequence AN, this AN will be a solution of the recurrence relation AN equal to C1 AN minus 1 C2 AN minus 2 if and only if A1 equals to alpha 1 R1 to the power n alpha 2 R2 to the power n for all n equals to 0, 1, 2, where alpha 1 and alpha 2 are also constant. Alpha 1 and alpha 2 are constant. শিক্ষার্থী একটু ভালো করে বুঝতে হবে। আমরা আবার বলছি যে r স্কয়ার মাইনাস c1r মাইনাস c2 এটা একটা ক্যারেক্টারিস্টিক ইকুয়েশন of a recurrence relation. This recurrence relation is an equal to c1 an minus 1 c2 n minus 2. This is a recurrence relation of degree 2. Here degree is 2. So if r1 and r2 be two distinct roots will be distinct. This root will be distinct or separate. Then a1 equals to alpha 1 r1 to the power n, alpha 2 r to the power n will be a solution. Will be a solution of this recurrence relation. Relating with this, we can discuss about a problem. Say, what is the solution? What is the solution of the recurrence relation an equal to an minus 1 plus twice an minus 2. This is the recurrence relation. You have to find out the solution of this relation. An equals to an minus 1 plus twice an minus 2. It is also degree of 2. With initial condition a naught equals to 2 and a1 equals to 7. There was given two initial conditions, a naught equals to 2, a1 equals to 7. That means if you put the value of n equals to 0, then a0 equal to 2 and a1 equal to 7. Now, if we compare the recurrence relation with this theorem, we can say that the characteristics equation or auxiliary equation will be solution the characteristic equation, or we can say it is auxiliary equation, characteristic equation of the recurrence relation is, what is the equation? R square minus r minus twice minus 2, r square minus r minus 2 equals to 0. You can relate my lecture, today's lecture, with last lecture. In my last lecture we discussed about this. This is the characteristic equation. It is an order 2, relation of order 2. That means r square minus r minus 2. R square equal to r plus 2. If we interchange the side, then we will get r square minus r minus 2 equal to 0. This is the recurrence relation of degree 2. So if we solve this quadratic equation, r square minus r minus 2, we will get two values, r equal to, and one value is 2, another will be minus 1. This is a quadratic equation. It has two roots. Here roots are distinct, which are distinct or separate. That means যে দুটো root আমরা পেয়েছি, these two roots are distinct. We said in this theorem, c1 and c2 the real numbers. Suppose that r square minus c1r minus c2 has two distinct roots. This is the recurrence auxiliary equation or characteristic equation, and here characteristic equation is r square minus r minus 2. Here the roots are r1 and r2. There the roots are r equals to 2 minus 1. That means r1 equals to 2 and r2 equals to minus 1. Hence, then the sequence an is a solution of the recurrence solution. Then an will be a solution of the recurrence solution, and the solution will be this. an equals to alpha 1 r1 to the power n, alpha 2 r2 to the power n. This will be the solution of this recurrence relation. So we can write down that hence the sequence AN is a solution to the given recurrence relation if and only if An equals to alpha 1 R1 to the power n, alpha 2 R2 to the power n. That means An equals to alpha 1 R1 means if we say R1 equals to 2, then it will be 2 to the power n plus alpha 2 also constant, and R2 to the power n, R2 means minus 1 2 to the power n. That means this will be the solution of that recurrence relation. Now we can use the initial conditions. The initial conditions, what is this? Here is A0 equals to 2 and A1 equals to 7. A0 equals to 2. Putting using initial conditions, that means if we put n equals to 0, then A0 equals to alpha 1, 2 to the power 0 means 1, plus alpha 2, A0 equals to alpha 1 plus alpha 2, n equals to 0 minus 1 to the power 0 means 1, that means alpha 1 plus alpha 2, but A0 equals to 2, so we can write down alpha 1 plus alpha 2 equal to 2. Again, if we put n equals to 1, then A1 equals to alpha 1, 2 alpha 1, 2 to the power 1 means 2, 2 alpha 1 and 1 minus, that means minus alpha 2. That means A1 equals to 7, then 2 alpha 1 minus alpha 2 equal to 7. Adding these two, we can say this is equation number 1 and this is equation number 2. By adding these two equations, we can say that alpha 2 will be cancelled, alpha 1 plus 2 alpha 1, that means 3 alpha 1. Adding 1 plus 2 implies 3 alpha 1 equal to 9, so alpha 1 equals to 3. Alpha 1 equals to alpha 1 equals to 3. Alpha 1 equals to 3, and from equation number 1 we can get alpha 1 equals to 3 plus alpha 2 equal to 2. That means alpha 2 equals to minus 1. Alpha 2 equals to minus 1. So what will be the solution? The solution will be this. Hence, the solution of the recurrence relation and initial condition and initial conditions is the sequence An with An equals to alpha 1 means 3, 3 into 2 to the power n, 3 into 2 to the power n minus alpha 2. That means alpha 2 means minus 1, that means minus 1 whole to the power n, and this is the solution of the recurrence solution. Alpha 1 equals to 3, alpha 2 equals to minus 1, and this is the solution of this recurrence relation. We discussed in this problem, when the roots are distinct, separate, but if the roots are repeated, I mean if only one roots, then what will be the condition? In this case, we can write down another theorem. Another theorem. Theorem is that if the roots are repeated or same root, that means, say theorem number 2, let C1 and C2 be real numbers with C2 is not equals to 0. With C2 is not equals to 0, then that means this will be the quadratic characteristic equation, or it is a reconciliation of degree 2. C1 with C2 is not equals to 0, Suppose that R square minus C1R minus C2 equals to 0 has only one root, R0 or R0. A sequence is we can say a sequence An is a solution of the recurrence relation. A sequence is a solution of the recurrence relation An equals to C1 An minus 1 plus C2 An minus 2 if and only if, we can use the symbol, if and only if An equals to alpha 1 R naught to the power n plus alpha 2 n R naught to the power n for n equals to 0, 1, 2, where alpha 1 and alpha 2 are constants. We can discuss about this. Here the auxiliary equation is R square minus C1R minus C2 equal to 0. This is also a reconciliation of degree 2, and it has only one root. Which is R0. Then the sequence will be a solution An equals to C1 An minus 1 C2 An minus 2. This recurrence relation has a solution An equals to alpha 1 R to the power 0 alpha 2 n. Difference is here. Alpha 1 R to the power 0 alpha 2 n R to the power 0. In the previous cases there was alpha 1 R1 to the power n, alpha 2 R2 to the power n, where the roots were distinct. And using this relation we can solve recurrence relation. Before solving a recurrence relation, we have to identify the roots whether distinct or repeated or whatsoever may be. Now we can solve a problem. What is the solution? What is the solution of the recurrence relation An equal to 6 An minus 1 minus 9 An minus 2. 6an minus 1 minus 9an minus 2 with initial conditions a0 equals to 1, a1 equal to 6. So what will be the solution? It is very easy. The characteristics equation will be the characteristic equation of the recurrence relation is r square minus 6r plus 9 equal to 0. This is also a quadratic equation. We can solve this. R minus 3 whole square equals to 0. That means roots are 3 and 3, only one roots. That means here r not equals to 3. This is our formula. R equals to r 3 comma 3. So this quadratic equation 3 comma 3, r not equals to 3. Repeated roots are in here. So what will be the solution? Hence the solution will be an equals to alpha 1 r naught to the power n. R naught means 3 to the power n plus alpha 2n r naught to the power n. Alpha 1 r naught to the power n, alpha 2n r naught to the power n. Using initial conditions, that means when n equals to 0, then a0 equals to alpha 1 3 to the power 0 1, and this will be 0. N equals to 0, it is 0. That means a0 equals to 1. So we can say that alpha 1 equals to 1, and n equals to 1. Putting n equals to 1, it will be a1 equals to 3 alpha 1 plus n equals to 1 3 alpha 2. But a1 equals to 6, that means 6 equals to 3 alpha 1 plus 3 alpha 2. Putting the value of alpha 1 equals to 1, that means 6 equal to 3 plus 3 alpha 2, that means 3 alpha 2 equal to 3 alpha 2 equal to 3. 3 alpha 2 equals to 3. So alpha 2 equal to 1. So what will be the solution? So the required solution is an. Required solution is an equals to alpha 1, that means 1 3 to the power n plus n 3 to the power n. Dear students, we discussed two theorems, theorem 1 and theorem 2. Theorem 1 was about the roots when the roots are distinct roots, and theorem 2 are when the roots are repeated or same root, and in that case we solved two recurrence relations. Next class we will come back another theorem. Okay, goodbye, thank you.